everyone. Thank you so much for joining our webinar this morning, Bare Minimum Developers Need to Know to Get Started with Kubernetes. We're glad you could join us. This is going to be a brief but very valuable session on an intro to Kubernetes, so hopefully you can leave today with a solid understanding of the fundamental concepts and how to get your first app up and running. We have myself, I'm Brittany Ingram, the marketing lead at CoFresh, and Raziel Tabib, co-founder and CEO of CoFresh, as well as Dan Garfield, VP of Marketing at CoFresh, on the line. And we invite you to ask questions either now or during the session, and we will, either answer them privately or try to get to them at the end of the session today. So if you have questions, make sure to just type those in the question box on your GoToWebinar control panel. And we will try to get to those as soon as we can. And with that, I will pass it over to Raziel, who will kick it off.
Thank you, Brittany, and hi everyone, good morning. Brittany, can you make me a presenter so I can share? Awesome.
Yeah.
Okay. So hi everyone again and welcome. In this session, as Brittany mentioned, we're going to go through an introduction to Kubernetes. A few words, Kubernetes is one of the most popular and very powerful platform for managing containers in production. As some of you have already seen, when you want to get started with Kubernetes and learn about Kubernetes, it might be a little bit overwhelming at start, as there are so many moving parts. And the intention of this session and this webinar is really trying to simplify and walk through the very basic entities that will allow you to play around and to run an application. A few words about myself. So my name is Raziel Tabib. I'm a developer entrepreneur. I live here in Silicon Valley for the past 9 years. Also the organizers of Containers 101 Meetup, which is both an online and in-person meetup. The online ones are also getting recorded and will be posted on our blog later on. And I'm also the CEO and founder of CoFresh, which sponsored this meetup. Few words about CoFresh before we start. So CoFresh is a platform for building, testing, and deploying containers. It is built for containers, it's optimized for containers, and basically automate the whole process of building the container, testing it, and deploying it. You can try us out at www.codefresh.io and follow us on Twitter at CodeFresh. Okay, so again, what is Kubernetes? Just before we start, Kubernetes, again, it's one among, I think, 3 popular ones, but I think it's the most popular one that we've seen so far for orchestrating, managing containers in production. The key strength of Kubernetes is actually that you can deploy changes on the fly. It's very easy to deploy changes and roll out changes to your application using Kubernetes. To scale the application, it's a very powerful, it's an open source project that was designed by Google. You can see some stats at the bottom about how active this project is. And again, once you get used to work with Kubernetes, I think you find out more and more about the benefits of it. As for what we will cover in this meetup, in the first part, I will really walk through some of the objects. There are many objects, there are many entities, again, there are many moving parts, but I'm going to walk through 3 main objects in Kubernetes that will allow us to spin up and see how we can scale a very simple microservices type of an application. We're going to go do it through live demo, and then we'll open it for question and answer. Some resources that are available. I've posted a blog that basically walks through similar steps, and you can find the link for that blog here. Also, the application that we're going to use for the demo, you can find it on github/containers101/demo chat. That's the application we will use in the demo today. So without any further ado, let me move to the first object, the first entity, which is pods. Pods is basically the smallest unit that you can deploy. Whenever you run a container, it has to run within a pod. That's really the very basic unit. You usually run one container in a pod. You can run more than one container, but to make things really simple, the most common situation is to run a single container in a pod. The only cases in which you want to think maybe I will run more than one containers is if you want to have two containers really sharing the same volumes. If maybe another way to say it, if in any other way you would have put these two containers, you would have forced them to run on the very same physical machine, then maybe you want to run these two containers in the same pod. But again, the most common case is pod is running one container. The second entity is deployment. Now, deployment is a super powerful entity within Kubernetes. Obviously, you can manage pods manually. You can create pods and shut down pods and so on. But the most efficient way and to really benefit from Kubernetes, you want to create pods, scale pod, using deployments. Deployments are basically entities that we will see later on that can help you in bringing up replicas of pods, monitor that these pods are working, and monitor the health status. If a pod fails, the deployment will spin up a new pod. If you want to roll out a new image, it will actually spin up a new pod with a new image and then shut down the old pod with the old images. So it really helps you to manage the pods, and we'll see that soon in the live demo. So as we can see here in the diagram, you can have a deployment, and deployment can manage multiple pods across multiple nodes. The last object, which is important for us, again, I'm going to go walk over only 3 objects for this demo. The last object is services. And what services are used is basically for communication internally within your Kubernetes clusters, and obviously also outside to the web. And basically what it says is, although each and every pod that runs in Kubernetes has an IP, it's easier to put a service that will actually have a persistent IP and port that whenever you want to reach out to one of the pods of a service, one of the pods, you can basically go to this service IP, and it will redirect and will have a load balance between the pods. So rather than directing a call to a pod IP, you just call the service, and then the service will redirect your call to one of the available pods. So again, if we're looking at this diagram here, we have pods that are running the containers. We have deployments that are monitoring these pods, spinning up, new pod if there is a need, and there is a service that really helps us if we want to call. If you want to call our containers, we can call them through a single point, a single IP and port, and the call will be redirected to the pods. Okay. Before we seeing how this all working, a little bit a background about the demo application that we will be using. We're going to be using a demo chat application. It basically, to run this application, we need to run 2 images, 2 Docker images, basically 2 containers at least. One of them is a web server, which is implemented in Node.js. The image is available on Containers 101 on Docker Hub /demo chat with the tag 2.0. It's also, the demo chat application itself, the code, if you want to build the image yourself, is on github.com/containers101/demo chat. And the Mongo, we basically took the latest Mongo image available on the demo hub, on the Docker Hub. The additional resources and what I will be using through this demo. So to have Kubernetes installed and working with Kubernetes, there are a few options. One very easy option is to use the Google Container Engine, GKE. or you can go and install Kubernetes on the cloud. What I will be using today, which is very convenient, especially if you're a developer and you want to play around with Kubernetes, is to use Minikube. Minikube is kind of a minimized version of Kubernetes that you can install locally on your Mac or on any other operating system, and then you can work directly against the node of the Kubernetes. In addition to that, we also need to have installed the kubectl, which is the client to work with the Kubernetes cluster. And lastly, I assume you have Docker, but you also need to install Docker. I have Docker installed on my machine. The flow that we're going to go back to this flow later on to see what we did. But the flow will be, after having both of these images, we will run the Mongo image first using a deployment. So basically, a deployment will be created, and this deployment will spin up a pod for the Mongo image. We will then create a service to expose the Mongo pod internally. So when you create a service to expose the pod out, you can define whether these pods are going to be exposed only internally to the other pods in your Kubernetes cluster, or if these pods are going to be exposed externally, so everyone on the web can access your pods. So the Mongo is going to be exposed internally. After that, we will be running the DemoChat web server image. In this very same way, a deployment and a pod will be created. In this case, we will expose the service of the DemoChat externally, not only internally. We're going to see how the application is running, and then we're going to try and see how we can easily scale the number of pods for the web server. Okay, without any further ado, I will switch to the command line and walk you through all of these steps. Okay, so that's to show you what I have here. So I have Minikube installed, version 0.17. Again, in the slides, there is how to install the Minikube. I also have Docker installed here. And the first thing that I would do, what really Minikube allows us to do, is to have our Docker client working directly against the Docker daemon in the Minikube cluster. So to do that, first of all, I'll show you that at the moment, if I do Docker machine ls, my Docker client is working against the default daemon within my my Mac. And what I will do an eval Minikube and then after running this command, basically, if I run Docker machine ls now, I'll see that my Docker client is not working against my installed Docker, but is actually going to work against the Docker daemon within the Minikube, within the Kubernetes, which allows me to really now pull images and run them inside the Kubernetes very easily. So the first thing we're going to do is I'm going to look at what images I have available, and we can see that what I did is I pulled the images that we're going to be using for this demo, both the Mongo latest and the containers 101 demo chat with a tag of 2.0. So let's go to the first step and actually run, create a pod and a deployment for the Mongo image. Okay. Can everyone mute the line? Awesome. Okay, so to do that, I will use the kubectl run. Again, this is one way to spin up, a very easy way to spin up deployment and a pod. There are additional ways to spin up deployments, pod, and services. You can use kubectl create -f and give a YAML file that describe the pod or describe the deployment or the services. kubectl run, it's very simple. So I do kubectl run. Let's give a name to the deployment. Let's call it Mongo for now, and then let's specify the image that you want to run. Mongo latest, and that's enough. When I click on run, we can actually see that deployment was created. If you want to see the deployment, we can do kubectl get deployment, and we can actually see that a deployment named Mongo created. We can also run get pods, and we can see that we have a pod with this name running. We can see the status of it. So the first step completed. We created very easy. We created a running container of the Mongo image inside a pod, and it's being managed by the Mongo deployment. The next step that you want to do is actually want to expose this this running container as a service. So we're going to run again kubectl expose. We're going to say we want to expose the deployment Mongo. You can actually give it a different name, but if I don't give it a different name, it will basically call it Mongo. Just a second. Oh, and I need to specify the port. Well, you know what? I should have specified the port when I'm running the pod. So in order to do that, let's just rerun the pod. So let's shut down the pod that we had, and to do that, we do kubectl delete deployment Mongo. And then what we'll see now is that the Mongo deployment was deleted. So if I do kubectl get deployment, we can see that there is no deployment here. But back to the point that we mentioned earlier, when I shut down, when I deleted the deployment, the pod will be deleted too. So if I do kubectl get pods, there is no pod running. So again, the default way and the most recommended way is just working with deployment, and this will spin up and shut down the pods. So let's rerun again the image. So we have the command here to run the Mongo. What we will also do is specify the port in this case. And now we created it, and we can see that we have the pod running, we have the deployment running, and now let's try to expose it again. So I do kubectl expose deployment Mongo, and actually now the service Mongo is exposed. So if we will run kubectl get services, we can see that the Kubernetes service will always be up. That's the internal service. But here we have a Mongo service running. It's exposed internally, which means that for every new pod that will be running, he can access this service. And there are few ways to access this service. One way is using the DNS and just simply call it Mongo. By default, the DNS driver is enabled for the Kubernetes, and all the services can be discoverable by their name. So if I'm looking at the code of our application, so this is the GitHub Containers 101 demo chart. If I look at how we actually connect into the Mongo, and let me go to, it's in the file defaults. Okay. When I go in, I can actually see that we are connecting to the database using just simply call it Mongo. And because our service name Mongo, this will be translated to the right IP where the Mongo service is running. Other than just using the DNS, also Kubernetes will set an environment variables in every running pod that will tell on all the available services their IP and their port. So going back here, we have the Mongo pod running, deployment running, and service running. Now let's run the demo chat pod and deployment. So we're going to do it in the very same way, kubectl run. Let's call it a demo chat. Specify the image. Demos 101, demo chat 2.0. Specify the port. And just a second, I'm running the image name. Okay. Okay, so I created it. I put the equals. Now let's do kubectl get pods. We actually see that we have now two pods running, the demo chat pod running and the Mongo running. If we do kubectl get deployments, oh, we have an error here of the image pool. Let me see why. I think maybe because I used the uppercase C. So let me do that this way. Let me do kubectl again in the very same way. Delete deployment demo chat. It's deleted. Obviously, if we're going to do again kubectl get pods, we can see that also the paths of the demo chat was deleted. Now we're going to run it again. This time, let me see, I think it's the uppercase, lowercase. Let's run it again. Let's see that it's running properly. It's actually running properly. We have both the pods running properly, and we also have the deployment. Let's see, kubectl get deployments. We have them both running. So we have the pod and deployment for the demo chat. Now we want to expose the demo chat so we can access it through the browser and see how the application works. So to do that, we're going to use again kubectl expose. We're going to expose the deployment demo chat. But in this case now, we're going to specify the type. And if we are actually running it on JKE or on the cloud and Amazon, and we really want to expose it to the internet, we're going to use -" type load balancer. But in our case, since we're using a local Kubernetes node, the way to do it is called node port. And then I'm going to run it and see now if we're going to do kubectl get services. You can actually see that we have the demo chat exposed. We have the service of it. We can see that it exposed. It maps the port 5000 of the application to port 32356 of the node. If you want to access this application, let's see it running. Let's run minikube IP. See the IP of the node. This is the IP. So let's go to the browser. Put the IP here. The port will be 32356. So we'll give it 32356. I think I forgot the one here. Second. Here, one. And here we have the application running. So that was a very, if we're looking at what the steps that we have done so far, basically we run a Mongo image using a deployment, and that created also a pod. Then we expose the Mongo internally, so it will be discoverable by its name is Mongo. It also can be discoverable using the environment variable. Then we run the demo chat image, and again a pod and a deployment container, pod and a deployment created. We then expose the demo chat. In this case, we exposed it externally, so we could have accessed it through the browser. Now, the last step that we're going to do is we're actually going to see how we can scale the web server pod and have 2 pods instead of 1 pods. So let's go back to command line. If we're looking again, kubectl get deployment. This is the deployment that we're going to scale, the demo chat one. So we run kubectl scale replicas equal to deployment demo chat. And what it actually now did is spin up another pod, and we can actually run the get deployments again. We can see that the demo chat is in fact running 2 pods now, which are going to have a load balance between them of this web server. If we will run get pods, kubectl get pods, we can see that there are 2 pods running for the demo chat. Now we can also see something very, let's play around with it a little bit. If I'm going to go, in fact, and now I'm going to kill one of these pods, let's see how the deployment will immediately identify it and spin up a new pod. And that, again, that's the resilience that we have with Kubernetes. It's always monitor all the pods across all the nodes. If a pod fails, it will spin up another pod instead of it. So let's do that. Let me copy the name of the pod. And now I do kubectl delete pod. I'll give the name of this pod. And when I deleted it, I can do get pod again. I can see there again, there are 2 pods here, but the pod that we deleted is not there. So we kill the pod, deployment saw it, and immediately spin up a new one. And again, that's one of the strengths and benefits of working with deployment and obviously working with Kubernetes as well. So now let's do a little bit of a cleanup before we summarize everything that we've seen and open it for questions. So what I'll do is I'll do kubectl delete, and then I can say delete services demo chat. That will delete it. I can do the very same thing for deployment. And in fact, it will also take the 2 pods down. And then I can also see kubectl delete services Mongo. In fact, I could have, one command line that delete services and deployments. I just want to see how you could. I just wanted to show how you do it one by one. And deployment Mongo as well. In fact, after we run it, if we run our kubectl get pods, there is nothing running. So let me just recap what we've seen and what we did. If I go back to the presentation, again, we've seen that we basically played around with 3 main entities. The first entity was pod, which is, again, that's the smallest entity that can run container. And that's the smallest deployable unit. In fact, we've seen that deployment, it's a very convenient object or entity to manage the pods across the different nodes, to bring up new pods, to roll out changes to the pod, to roll back changes, and so on. We have seen services, which is a way to expose our pod in one IP and one port, and it helps us to communicate both between pods internally within our Kubernetes cluster and externally. And then we've seen how we did a live demo with the Demo Chat application, in which we first of all run a pod for the Mongo and a deployment for Mongo, expose it through a service internally, then run the Demo Chat. Okay, Before I open it to questions, let me share with you some of the resources. So again, the flow and everything that I have presented in this webinar, including very detailed instructions of how to set up Minikube on your Mac, is available here in this link. You can also find additional interesting talks about containers on CoFresh.io blog, and you can register and find out about future meetups that we will have at CoFresh.io/meetups. Okay, now let's see if there are any other questions.
Great. Yeah, actually, we had a couple of really good questions during the session, Raziel. So one of the first ones that I saw that I thought would be good is there's a best practice in Kubernetes for one container per pod. Can you comment on that and why that is and what that means?
Sorry, I couldn't hear the question.
Oh, when...
Okay, so the question is when to make an exception and run two containers in the same pod. So again, I think the rule of thumb here is that if there are two containers that you would have been forced to put them on the very same physical machine because they really sharing the same volumes and there is a need for them to be on the same machine, then you would have put two containers in the very same pod. The best practice is actually to have, if there is no need for that, and in fact these containers can run also on two different machines and they can communicate through services, to just run a single container in a pod.
Good. And then we had another question, just comparing Kubernetes to Docker Swarm. What would you say is the advantages and disadvantages of each one?
Okay, so that's a very good question. I think we walked through Kubernetes here, which is again a very popular orchestration project. There are additional orchestration platform such as Docker Swarm and Mesosphere. In one of the future blogs, we're actually webinars. We're going to give a detailed comparison between them. I think in a nutshell, for this introductory session, I would say Kubernetes has been out and a little bit more advanced at the moment than Swarm. Swarm is moving pretty fast as well. So recently Swarm added Secret, which was available in Kubernetes for quite some time. So it seems like Kubernetes it's still a little bit ahead of Docker Swarm. Also, with respects to the mileage and the adoptions of Kubernetes, again, from just the surveys that we run, I want to put that disclaimers. We've seen Kubernetes more adopted out there, and hence has more mileage and active community that helps you, tackling issues and so on. Again, without saying, I think Swarm is closing the gaps pretty fast, but I think that's sufficient for this level of introductory. Again, there will be a dedicated session just comparing Mesosphere, which is also a very robust orchestration platform built for a large organization specifically, and then there's Kubernetes and Swarm.
Great. We have lots of questions actually, and I think we have time to run through most of these. Somebody just asked, this is a fairly basic question, what's the difference between a node and a pod, just to reiterate that?
Okay, node is in fact is like you can think about it as a VM. You can have multiple VMs running pods, and in fact you might have your Kubernetes running multiple nodes, managing multiple nodes. When you are working with pods, and when you're working with deployment, you basically want to be agnostic to that. So you want to manage your application in the pods level, in the deployments level, and in the services level. And nodes are, again, VMs or physical machines that the Kubernetes will utilize to run your pod. If one node, if one VM or one physical machine failed, it will move the pods to the other running machine. So again, node is more equivalent to a VM or a physical machine. Pod, think about it like when you run, a native Docker, you can run containers. So pod is to some level a container, but it's a container with a small wrap around it that Kubernetes called pod. And node, it's more of the physical machine or the physical machine or VM.
Good. And then we had a question just about, and it kind of going off of that. When does a pod run on more than one physical machine? And when do you have, are pods always bound to a single machine? And a machine, is it bound to a single pod? How does that relationship work, and how does it scale as you grow the number of pods?
So again, the pod is not binded to a single machine, and you can, when you scale a deployment to run multiple pod, the best practice is actually to have this pod distributed across multiple nodes. In fact, and that's by the way recommended. I think for some of you who work with AWS and seen what happened when the node and everything in Virginia last week failed, how many applications actually failed. But if you would have physical machines across different regions and you would have your pods running across, you can actually make sure that when a node failed, you have other pods running. In fact, if the Kubernetes will make sure that also it will transfer pods, it will not transfer pod, it will create new pod. So that's a good correction. You not transfer pod. The deployment is always creating a new pod. So when we actually want to roll a new image to the application, the way the deployment will do it, it will actually spin up a new pod with a new image. And when it's running properly, it will start directing the traffic from the old pod, from the service, not to the old pod, but actually to the new pod. And after all the traffic is going to the new pod, it will shut down the old pod. And again, to which nodes it binds, it's pretty agnostic, at least to you as a user.
I think you kind of answered this question, but maybe just in a different way. When you have a deployment, it's basically a load balancer for the different pods that are inside of that deployment, correct?
The service is more of a load balancer because the service provides you one IP and a port, and when you direct a call to that service, then it being load balanced between the different pod. The deployment is more of kind of a monitoring the health of the pods and spin up a new one if one of them fail, and actually taking commands such as scale up and scale down, roll out changes, roll back changes, and so on. So I would more look at the services as the load balancer sort of thing.
Gotcha. So if you want to have multiple web servers that are all basically exposed on the same port, on the same IP addresses, those are just part of the same service.
Yeah. So if all of these pods represent one microservice within your application, then they're all being exposed through a single service. If you have, if they represent different microservices, then you would have different services.
Good. And then let me see if I can succinctly ask this question. What are the impacts here on stateful applications for Kubernetes? Can you have stateful applications inside Kubernetes?
You can have. Obviously, what I've shown here, it's a non-stateful, but you can have. In fact, we can send later on. There are lots of articles that talks to you about how you can work with stateful application. The demo that I work now is actually not a stateful one, but there is a way to work with stateful application and manage the session that starts against one pod to continue with the same state. But again, that we can send this info about how to do that. It's not covered in the webinar today.
Getting a couple of questions here, just trying to cruise through these. Okay, we didn't really get into what happens when you upgrade an image. So if you upgrade an image, I believe there's a time when, as it goes out into a service where you have the old and the new image can both be in play in different pods, basically, right?
Yes. So during the rollout, initially again the pods with the old images will be running until all the traffic can be redirected to the new pods with the new images. And that's, again, one of the benefits of Kubernetes, of rollout changes on the fly. So the deployment is, you're going to tell deployment there is a new image. You're going to give, update with the new image name. It will spin up. So if you have 3 pods running the old images, it will spin up 3 pods running the new images. And then once all the traffic are moving to the new pods, it will shut down the 3 pods with the old images.
Good. And then somebody asked about production examples. Do you know if we have any good production examples that we could share with people after this?
Yeah, we can. In fact, the next, if you are around here in the Bay Area, we're going to have the next webinar actually going to be talking about running Kubernetes in production. In fact, we're going to have here one of our customers sharing how they are running Kubernetes in production. We're also going to have an online webinar in which I think it will be useful to come and see. We are running Kubernetes. Our platform is running on Kubernetes as well. So we're going to have Oleg, which is our CTO, showing the benefits that CoFresh is having from running CoFresh on top of Kubernetes.
Yeah, that's actually probably a good time to pitch our newsletter. If you sign up on our newsletter, it's on that link for codefresh.io/meetups. If you sign up on the newsletter, we'll let you know about these events that we have upcoming. We're actually doing a series on orchestration. We're going to be talking about Mesos. We're going to be talking about Docker Swarm. We're going to be talking about running in production. And basically building off of this this training that we've done here today. So let's see. And then somebody asked, how do you scale up the MongoDB in this application? The address so far is fixed in the application, is what the comment says.
Yeah. So again, in this case, I didn't scale the Mongo because with Mongo it will be a different scaling of a database. If I will create another, in that case, if I will create another instance of another pod of that Mongo, in fact, there is no data synchronization between the very same pod. That's why I actually scaled the web server, which is, as we mentioned before, it's a stateless. It's not a stateful. For Mongo, it will be done differently, and when we're going to talk a little bit about stateful application and how to share and how to cluster databases, we will be covering that.
Cool. Yeah, and actually on that same topic, a lot of people have asked questions about security. Here we're running everything locally. This is really about just getting familiar with it. We are going to do a whole session in, I think, it's about 4 weeks on security. So we definitely want to tune in for that.
What I suggest is maybe Dan, we can send the audience here what are the most concerning topics you would like us to talk about. We would love to hear from you, and then tailor our schedule of webinars to cover these issues. Again, the intention in this webinar was, I know if you're going to go outside and you're going to look for introduction to Kubernetes, I've done it. I've done it myself. Not so long ago, I find out that you can be overwhelmed, when you start learning just about how the platform look like and the etcd, database that it used for the data and kubectl and so on. So I think it's good to know it, but the intention in this webinar was just walk you through the core 3 entities that will allow you as a developers to play around with Kubernetes, understand the main concept, and hopefully to give you enough appetite to say, okay, that's powerful, that looks great, I want to learn more. And in fact, in the next session, we can tell you about secrets, which is a way to kind of pass credentials and mount them to pods. So you don't have to really explicitly tell in your code or in your Docker file or in the YAML file explicitly mention your credentials to other services or database or S3 that you're using, but actually use secrets to pass these credentials. There is so much more to learn. Again, we haven't covered it in the webinar today. I wanted to keep it, my intention was to keep it really simple, especially if you're a developer and you have maybe some experience with Docker and Docker Compose, which also allow you to spin up multiple services. Many are asking, how can I do it in Kubernetes? I've demonstrated it in this webinar. And again, I use Minikube, which is also, if your whole intention is just to play around, get yourself familiar with pods, deployment, services, secrets, Minikube is your option. So yeah, that's
Good.
it.
There's a question here about, well, this is a fun one. Someone asked if we would cover travel costs to visit us for one of our offline events in Mountain View. I would say that we offer pizza and beer, which is fuel for your feet. So if you're able to move here with your feet, you're welcome to join us at any of those events. Somebody had a question about CoFresh itself and how we integrate with Kubernetes. And they asked specifically, is CoFresh considered a platform as a service?
Yeah, so CoFresh, that's a good question. Again, CoFresh is a platform for the dev team. It really, again, streamlines and automates the building, testing, and deployment of containers. The deployment itself is agnostic, so we have an out-of-the-box steps to deploy it to Kubernetes and out-of-the-box step to deploy it to ECS, and the end of the pipeline, or to deploy it to Swarm. But it's basically a platform that helps you as a developer make sure that all of your containers are being built, and we have implemented and leverage the latest and greatest from Docker to provide you the fastest Docker build process. It can spin up your Docker image and test it against your unit test, integration test, and so on, and also automate the deployment. Specifically on deployments from CoFresh, again, this is another topic that we're going to have this month, showing about how you can, in a 5-minute setups, have CoFresh plugged into your source code management and automate every commit from building a Docker image, running the test, and deploying it to Kubernetes. There's going to be a subsequent webinars that to show that the very same thing for ECS and Swarm and so on.
Great, great. I think we probably only have time for one more question here, and I do see a number of questions about production, which again, I think we're going to have to cover more in depth in another session, so please join us for that. But just the last question, and this one is kind of production related, is just at a high level, how does Kubernetes interact with a service like AWS?
Yeah, so Kubernetes, in fact, you can set it up on AWS EC2 in a very same way that you can install it on Azure or GCP yourself. There is, again, I don't want to promote one vendor over the other, as all the cloud vendors are good, but the benefit of using actually the Google Container Engine, the GKE, is that you already get Kubernetes as a service, but not only that you're getting Kubernetes already set up for you, they're also making sure that you always get the latest Kubernetes running, and all the updates to Kubernetes are being deployed for you automatically, and you don't need to spend any time on the maintenance of the Kubernetes. So again, you can do it, and we have customers that are installing manually Kubernetes on AWS EC2. We have others that are using the Kubernetes on GKE, the Google Container Engine. For developers, Minikube which is, again, it's an open source project as well that was contributed and mainly built by a company named Red Sauce. So give them the credit for making our life easier. Is the way for developers to kind of play around without going through the whole process of setting up a real Kubernetes in the cloud.
Great. Well, thanks, Raziel. That was really, really valuable. It seemed like we had a lot of questions there. So if you think of any after the session, feel free to reach out to us. I will be sending the recording of this webinar over the next couple of days, so make sure to look out for that. And yes, we'll definitely keep you guys updated on our upcoming webinars and meetups. We'd love your feedback and ideas for anything you'd like us to cover. So thank you so much for joining us today, and we hope to see you at our next event. Thank you.